Hello, this is Tracy Yates, and this is another exciting episode of Reality Check Radio. And this week, we're going to talk about quantum entanglement. And quantum entanglement has both puzzled and fascinated physicists for over 50 years, easily. And Einstein called it spooky action at a distance. And quantum entanglement seemingly defies the laws of physics because Einstein, according to Einstein, the speed limit of the universe is light speed, and light speed is 186,000 miles per second. And nothing, according to Einstein, can exceed this speed. So if you're traveling from point A to point B across the universe, you're going to do it at light speed and never anything more than that. But when we go to the quantum level, because Einstein's talking about the macro level, which is the larger things we observed, the physics on the larger level, in other words. When we go to the quantum level or the micro level, it seems to defy the physics that are on the macro level. Because on the quantum level, they can entangle a particle like a photon or a any kind of electron, for example, or entangle a quantum particle, meaning join them. So they're like for example, identical twins per se. And what Einstein couldn't understand is when you join these particles and then you separate them again, one will have an upward spin and one will have a downward spin. And you can take these particles and you can put one on the moon and one on the earth, or you could put one on the earth and one on Jupiter or Mars or on the other side of the universe. The distance doesn't matter. What was blowing Einstein's mind was that no matter what distance apart these particles were, when you change the spin on one particle, say the particle that we have with us, it has a upward spin. When you change this particle spin to a downward spin, the joined particle, even if it's on the other side of the universe, 13 billion light years away, will instantly change to the opposite spin. Not at light speed, but instantly. And Einstein couldn't wrap his mind around this because it defied the laws of physics on the macro level, or it seemed to. So he called it spooky action at a distance. And this, just so this may be easier to understand, I wanted to hopefully share screen here and get to, hold on one second. I'm making sure that the share screen is going to work for me. Okay, I'm hoping this is sharing here. And I wanted to get to what is quantum entanglement, which is what we're talking about. And it says here, I mean, they're kind of making a joke, but it says entanglement is one serious long distance relationship. And it says quantum entanglement is when two particles link together in a certain way, no matter how far apart they are in space, their state remains the same. Quantum entanglement is a bizarre counterintuitive phenomenon that explains how two subatomic particles can be intimately linked to each other over even if separated by billions of light years of space. Despite their vast separation, a change induced in one will affect the other. In 1964, physicist John Bell posited that such changes can be induced and occur instantaneously, even if the particles are very far apart. Bell's theorem is regarded as an important idea in modern physics, but it conflicts with other well-established principles of physics. For example, Albert Einstein had shown years before Bell proposed this theorem that information cannot travel faster than the speed of light. Perplexed, Einstein famously described this entanglement phenomenon as spooky action at a distance. So, hold on one second. My computer's kind of freezing up here. So, what is quantum entanglement? Um, a physicist explains Einstein's spooky action at a distance. A multitude of experiments have shown the mysterious phenomena of quantum mechanics to be how the universe functions. The scientists behind these experiments won the 2022 Nobel Prize in Physics, and I'm hoping after this video they give me the Nobel Prize because I'm going to show you actually how this works, and to the best of my knowledge, nobody has ever demonstrated this before, and I think they were all overthinking everything without considering the facts of how quantum physics works and how the physics on the macro level work. And they're not contradicting each other, even though this seemingly appears that it would be that quantum physics and a particle reacting across the other side of the universe instantaneously would defy physics on the larger level that we see as pertaining to nothing travels faster than light speed. Therefore, something reacting on the other side of the universe in an instant seemingly defies what we see in quantum physics. So there seems to be a contradiction, and this is the what has puzzled physicists, like I said, for the last 50, 60 years or more, because it seems that the quantum level defies the micro level defies the physics we see on the macro level. And they've taken this to the ninth degree, even trying to come up with the theory of everything to try to somehow unite the macro with the micro, to somehow explain how things can react instantly across the universe at the quantum level, seemingly. But at the bigger level, the macro level, things can't exceed light speed. So, like I said, people, physicists, and really smart people, including the guy that is the acclaimed smartest guy in the world with an IQ of 200 and something, try to come up with a theory of everything to unify this, to explain it. And so far, nobody's really done that. So, anyway, moving on. What is quantum entanglement? A physicist explains Einstein's spooky action at a distance. A multitude of experiments have shown the mysterious phenomena of quantum mechanics to be how the universe functions. The scientists behind these experiments won the 2022 Nobel Prize in Physics. I already read that. The 2022 Nobel Prize in physics recognized three scientists who made groundbreaking contributions in understanding one of the most mysterious of all natural phenomena, quantum entanglement. In the simplest terms, quantum entanglement means that aspects of one particle of an entangled pair depend on aspects of the other particle, no matter how far apart what lie they are, or what lies between them. The particles could be, for example, electrons or photons. And an aspect could be the state it is in, such as whether it's spinning in one direction or the other, whether it's going up or down. The strange part of quantum entanglement is when you measure something about one particle in an entangled pair, you immediately know something about the other particle, even if they are millions of light years apart. This odd connection between the two particles is instantaneous, seemingly breaking a fundamental law of the universe, Albert Einstein, which is light speed. Albert Einstein famously called this phenomenon spooky action at a distance. Okay, so I wanted to move on here to the next part of the screen here that I wanted to show you guys. So bear with me one moment. I'm sorry, give us. I'm just going to the next article pertaining to what we're diving into here. Unfortunately, my computer's freezing up a little bit. It's buffering. But I should have restarted it, forgive me, before I even considered doing this. But anyway, we'll get there in just a second. This way you guys can kind of see all the weird things I look into as we're getting to, including impractical jokers, as we're getting to, yeah, I have a sense of humor, as we're getting to the subject matter I want to share with you guys. So, like I said, my computer's really, really wanting to freeze up here. But it'll be worth your time. Trust me, because I have a demonstration to show you. And as far as I know, nobody's ever done this before. So I hope they give me the Nobel Prize for this. Or at least maybe the Dunning-Kruger effect prize, you know. But I'm hoping that's not it. You know, I'm hoping that they can give me the Nobel Prize for what I'm about to show you. So almost there. Really close. Exactly. And this actually gives you guys a unique view of the things, you know, that I research, you know, and some of the things I watch. But this is what we just went over right here. And this is the second thing we just went over. Okay. What I'm trying to do, I have the anyway, my hold on one second. Okay. Stop sharing at this moment. I guess that was it. I thought I had more subject matter to share with you guys. But basically, sorry about that. My computer really was lagging. Basically, through the years, as I stated, it seems that things on the small level, the physics on the small level, the micro level, defy what we observe on the macro level, which is light speed. And that's what we're talking about. It seems that things on the quantum level can communicate instantly back and forth, even if they're 13 billion light years away or the width of the universe. And that defies light speed. That's why Einstein calls it spooky action at a distance. But what they're forgetting here, and this is my theory, and I'm not a physicist, so they may call it the Dunning-Kruger effect, which means I'm not smart enough, or I'm not a physicist, so I haven't studied into this enough to know what I don't know. But that could apply to anybody because nobody knows everything about the universe. So at some point, that the Dunning-Kruger effect applies to everybody, regardless of a college degree or whatever. And they oftentimes deny the logic of somebody if they don't have a degree in physics or whatever they're talking about. They'll deny their logic because it's not the same logic that they've been indoctrinated to believe in. And they deny this oftentimes through what they call peer reviews. So I can, for example, come up with something that I think explains all this logically and submit it for a peer review, which means all these physicists that have went to college at Harvard and Stanford and all these different prestigious colleges will come along and review my findings. But the problem here is peer reviews are very, very biased, and they are biased pertaining to what these peers, which are these people with degrees in physics and stuff that have been programmed to believe what the status quo, the system teaches them. So it's hard for them to look outside of the box. So you have somebody like me that comes along that thinks outside of the box and puts a theory before them, and they'll reject it in a peer review because it doesn't line up with the things they've been taught or told or led to believe. And this has been true for thousands of years. I mean, take Copernican or whatever his name was that came along 1,000 years ago, I believe somewhere around then, and said, hey, maybe the Earth is not flat, it's round, spherical, and maybe it revolves around the sun. At this time, everybody thought the Earth was at the center of the universe and that everything revolved around the Earth. Now, I'm not taking a side either way here. I'm just showing how biased the system is when somebody comes up against it. They burned this guy at the stake because he suggested something that went against what they had been taught and told for hundreds or thousands of years. And thank God they don't burn you at the stake these days for going against the status quo, but they definitely almost always reject it offhand because it's not what they've been taught or told. That being said, I'm going to give you my theory, on what Einstein calls spooky action at a distance, and or quantum entanglement, same thing. So, so what we have here is in quantum physics, and that was the last page I wanted to show you guys, which for some reason wasn't up there. But it shows that in pertaining to quantum physics, the universe is one unit as a whole. You could look at it as like lattice, a weaving pattern of lattice in a sphere, most likely. Some people believe the universe is a flat plane of existence. Others believe it's spherical. I lean towards the spherical, as I wrote in my book called The Bible Code Solved, where I explain reality from the quantum level up, according to God's word, and provable and created actually by the word of God. But anyway, um, so the universe is connected at the quantum level. It's not separated. It's all one spherical unit. I believe the shape of the lattice is hexagonal, just like a beehive shape. It's the most precise and efficient shape there is for joining everything together. And I believe that's the shape of the spherical universe at the quantum level. And it's as if you could make a honeycomb-shaped beehive into a sphere, and then these shapes would continue to connect throughout the sphere, not just around the edges of it, as this information is shared. And since it's one unit and not literally separated, see, in our minds, we see it separate. We see these stars in distant galaxies, and we know that we travel in a linear path on the macro level. So we see things like Einstein said that nothing can travel faster than light speed. If I was to travel to the other side of the universe, it would take me 13 billion light years if I was going light speed, according to science right now. I mean, and maybe the James Webb telescope is changing that and the universe is bigger. There's always new discoveries, but we're going with what we know right now. So, according to the speed limit of the universe, which is 186,000 miles per second, light speed, it would take me 13 billion light years to get to the other side of the universe. But that's not what they observe at the quantum level. At the quantum level, they could put a particle on the other side of the universe, and they've done tests to prove this. This is not theory, this is fact. They could put a particle on the other side of the universe, and if they change the spin to an upward spin on this entangled particle that is with us here, the entangled particle on the other side of the universe would immediately take a downward spin, the opposite spin. And if they change the one with that's with us to a downward spin, the one on the other side of the universe would instantaneously take an upward spin. And that seems to defy the laws of physics because it's impossible, according to things we observe on the larger level, to react instantaneously when they're 13 billion light years away as we travel linear. Now I'm going to show you why that's not impossible, why the tiny things or the micro or things at the quantum level do not defy the physics we observe at the macro level. So be sure they get me my Nobel Prize because I'm going to show you that and how it works. So, for example, take these two dots on this balloon, and the balloon represents the universe. And these two dots are right next to each other as entangled particles in our universe. And we're going to make them travel from one side of the universe to the other. Okay. Now, I'm sorry, the dots got substantially bigger after I blew them up, but that doesn't mean that I can't continue to show you how this works. I'll just make a smaller dot where the bigger dot's got. Okay, so here's one dot, and here's the other dot. Okay, they were close together, but now because everything expanded, this remember this balloon is the universe, the spherical universe, and this is a quantum entangled particle that is entangled with this particle that is, let's say, the universe is 13 billion light years from side to side, or so let's say in diameter. So let's say that this is 11 billion light years from this quantum particle to this one. So if you're going to travel from here to here across the universe, it will take you 11 billion light years. Now, you saw how they moved apart as I blew up the balloon. What's my point? My point is at the quantum level, they're all connected, like they're connected on the surface of the universe here, which represents the balloon. So even though in our perspective, it would take 11 billion light years to travel from here to here, at the quantum level, they're still all connected, meaning that if we were to put this in a downward spin, this particle, this particle would instantaneously take an upward spin. Easy, simple. It's all connected. This vast distance from here to here is meaningless because it's connected. So I put this particle into a downward spin. Guess what? At the same exact time, this particle goes into an upward spin instantly because it's connected at the quantum level in the universe, the balloon representing the universe. I take this particle into a downward spin. This particle instantly goes up, even though it's 11 billion linear light years away, because it's connected at the quantum level. It's one unit in the universe, just like it's one unit on the surface of this balloon, which represents the universe. You saw me blow up the balloon. You saw it go linear way further away from each other, which is represents our macro level and represents how long it would take in linear light speed to get there, 11 billion light years. But since it's all part of one unit, it's all connected at the quantum level. If I change this into a downward spin, this one will immediately go into an upward spin. Are you getting this? It's not that complicated, but this is something they've been puzzled about for 50 or 60 years. If I change this one to a downward spin, this one will automatically instantly go to an upward spin because it is connected in one unit at the quantum level. The universe is all one unit. And it doesn't matter if there's more dots in between. Say these dots are stars per se or quantum particles. It doesn't matter if there's more in between. Say I'm comparing this one to this one. If I bring this one down, say these are 5,000 or 5 million light years apart, or whatever you want to say. But if I bring this one down, this one will instantaneously go up. And if I bring this one down, this one will instantaneously go up. And it doesn't matter. You can do this all over the place. And it because the universe is united at the quantum level, all one unit, everything reacts instantly at the quantum level. It's pretty simple. But this is what Einstein couldn't figure out, and what Einstein called spooky action at a distance, because seemingly it defied light speed because they react instantly. But as you can see, they only react instantly because they're part of one connected unit that is the universe. And since the universe is connected, if this side goes up to an upward spin, this one necessarily has to go into a downward spin instantaneously because it's all one at the quantum level, all united and connected. I know I made this dirt simple. I know it is really more complicated than that because everything, the universe is a hologram, it has a holographic nature, and everything is formed from energy, frequency, and vibration, as Tesla said. Even so, even though that is true, this could be this could be a hologram, an electrical hologram, and it would be the same exact thing. If I turn the hologram, it's going to do the same thing. Then nothing changes. That's what I'm trying to say. So, in my opinion, that completely explains what they're observing with protons and electrons in what they call quantum entanglement at the quantum level, as opposed to what seemingly is defying light speed at the macro level. As you can see, it doesn't defy anything. It all is unified once you understand that at the quantum level, everything in the universe is one unit and every action has an instant reaction because it's all connected. So it doesn't really defy light speed. It has to react instantly because it's all connected. Anyway, I hope that makes sense. I hope that helps explain this. Be sure to recommend me for the next Nobel Prize. Anyway, God bless you guys, and that will conclude another exciting episode of Reality Check Radio.